Hi, hello everyone. Welcome to VR Signals. In this video, we are going to discuss very important questions on trigonometry chapter. So it's very important chapter, and in this video, we are going to cover every kind of concept that might be asked in your board exam. So please watch complete video and practice along with me. Here is your first question. If sine A is equal to 3 by 4, calculate cos A and tan A. We all know that trigonometry terms are completely applied to the right angle triangle only. Okay, so and also I want to tell you one thing. If it is a 2 mark or 3 mark or 4 mark questions or 5 marks, okay, you have to write everything step by step. Okay, you need to write everything step by step. But if it is a 1 mark question, you cannot need to write. You can go do directly how I did in the previous video. Okay, I just did direct method in 1 to 2 steps and I just mark the answer. But if it is a 2 mark, 3 mark or 4 mark, so based on the marks only, you have to write the length of the answer. The length of the answer depends on it. Okay, so it might be asked either for the 2 marks or 3 or 4 or 5. But there is a method, there is a procedure that I want to show you how you have to present in your exam. Okay, so first you have to write like let us assume let us assume or let us say that it is a right angle triangle. Okay, it is a right angle triangle. So it's sine A equal to 3 by 4, right? So okay, sine A, B, C. And they told sine A, this sine A is equal to 3 by 4. And we all know that sine A is equals to opposite by hypotenuse, that is equals to 3 by 4. Okay, so don't write directly 3 directly 4. No, now opposite side will be is equal to 3 into k, 3k. Why we are mentioning k here? The reason why we are mentioning k is it is in the ratios. So if you want to get a value from the ratios, it has to be multiplied with a constant. Okay, for example, if I take like uh, 12 by 16. So when I cancel this, 4 threes are 12. See, I'm writing here. 4 threes are 12, 4 fours are 16. Okay, so which is common here? 4. Here 4 is the common constant, that is k. If I multiply 3 with a constant k, then only I'll get this 12. If I multiply 4 with a constant this 4, then only I'll get 16. That is the reason. So now we are seeing 3 by 4, but we don't know exact what is the real answer. So this 3 has to be multiplied with some constant, then only we will get the final answer. So we are multiplying here 3 with the constant k. Okay, and I'm also assuming that hypotenuse side will be 4k. That k will be common. It might be any other number. Okay, done. But when you go to your 1 mark questions, when you're doing that, no need of doing all this k, because at final this k will get cancelled. That's the reason I did directly over there, because it's a 1 mark and there will be no more time for you to do all this procedure. So but if it is a 2 3 or like this, please attempt it step by step like how I'm doing here. All right. So opposite side is 3k and hypotenuse is 4k. Done. And and by using Pythagoras theorem, okay, by using Pythagoras theorem, so we all know that hypotenuse square 4, and you have to write it, okay, based on the marks. If it is a 4 marks, you have to write neatly hypotenuse square is equals to base square plus height square. You write it step by step. Don't miss it. 4k square is equal to base is 3k whole square plus height square. Done. So 16k square is equals to 9k square is plus height square. So height square is equals to 16 minus 9 is how much? Yeah, anybody here? Yes. 7, sorry, yeah. Height square is equals to 7k square. Height is equal to root 7k square. So this k square and the root get cancelled. So root 7 will be like that only and k will come out. So height we got it as root 7k. Okay, now we know all the three sides and we have to find out cos A and tan A. Come on. Now cos A is equals to adjacent by hypotenuse. Adjacent is what here? For cos A, the adjacent will be root 7k. Root 7k divided by 4k. So k cancel, root 7 by 4. So in 1 mark questions, that is the reason I didn't mention k, because finally it will be cancelled. But when coming to step by step, please go through this kind of procedure, include k, okay? And then coming to tan A we know that opposite by adjacent. So opposite is what? 3k by root 7k, hence answer is 3 by root 7. Done. Yes. Let us move to next question. If angle A is equal to angle B are acute angles such that cos A equal to cos B, then show that angle A is equal to angle B. So again, let us assume you have to write this down because of I don't want to make this video too lengthy. So I'm not writing every step in detail, but in your exam you have to write like this. Let us say that let us say that it is a right angle triangle. In this right angle triangle, angle A and angle B are acute angles. Okay, first draw the right angle triangle A, B and C. Okay, and they told this angle and angle B are acute angles such that cos A is equal to cos B. Show that angle A equal to angle B. So what is cos A? Cos A is opposite by, sorry, see how I got confused. Yeah, cos A is adjacent by hypotenuse, right? Even cos B is also equal to adjacent by hypotenuse. Then what is the difference here? Here the difference is the angle. Here it is A. So what is the adjacent side of this angle A? The adjacent will be this one, BC. Yes, no. This is the opposite side, right? The opposite side of A is BC, and the adjacent will be this AC. AC will be the adjacent for the A. AC by. Is it correct? I shall see. I'm confusing you. Yeah. So no. This is a hypotenuse. Okay. This is a hypotenuse for a right angle triangle. So for this angle A, BC will be the opposite and AB will be the adjacent. Okay, we don't take the hypotenuse. Hypotenuse is constant, it is standard. Okay, we can't change it. Now what is adjacent for angle A? AB by AC. Coming to angle B, so this is angle B. For angle B, what will happen? For angle B also, the adjacent will be AB only. Yes, AB by AC. Okay, done. So let us see. They told the condition. Always go with the condition. They told that cos A is equals to cos B. So cos A is what? AB by AC is equals to AB by AC equal to, again cos B is also AB by AC. See what is happening? Both are equal. No. Yeah, both are equal. So can I prove directly that both are, since both are equal, angle A? No. This is not the right proof. So where do we go? Where have we gone wrong here? So come on, check. Yes, what I have done here is I have taken the right angle triangle where angle B, at point angle B, it is a making 90 degrees. So this didn't work out. So now what I'm doing, okay, I'm doing it again. See, now I'm taking a right angle triangle where I'm taking C as my C point as the 90 degrees. And this is A and this is B. Okay, here I have taken B, but here I am taking now, I am changing it to C. Now let me check it. So now cos A will be what? Cos A is equals to AC by AB, and cos B will be equal to cos B. For cos B, what will be the adjacent? BC. Okay, now it's changed by AB. So I'm equating both of them. AC by AB is equal to BC by AB. AB cancel and AC is equal to BC. See, now we are telling that AC is equals to BC. From the isosceles triangle theorem that you have studied in before, from isosceles, sometimes spellings makes me confused, you know. Yeah, from isosceles something from isosceles triangle. Yeah, what we know is AC is equals to BC. So when two sides are equal, the respective angles are also equal. Hence, you have to write this from isosceles theorem. When two sides are equal, the respective angles are also equal. Hence, angle A and angle B is equal. This is the proof. Okay, so the reason that I have taken this also is to understand. Most of us, we start doing, we just take a right angle triangle, we just mark however we want and we keep on doing, but no, sometimes it doesn't work out. So we have the points that you put also matters. Every small detail matters in maths. Okay, yeah. In triangle PQR, right angled at Q. So here, see, in this question they are exactly mentioning that it is right angle at Q. So I'm drawing a right angle triangle. Okay, and it is at Q point, and this is P and this is R. Okay, PQR. So they told that PQ plus QR. Write down the conditions what they have given. PQ plus QR is equal to 25 centimeters, and they also told PQ as 5 centimeters. Okay, PQ is equals to 5 centimeters. So let me substitute this PQ in the equation 1, that is PQ plus QR. 5 plus QR is equals to 25 centimeters. Then we get QR as 25 minus see here. Here I have been copying the question. Answer is wrong. See, it is PR, not Q. The same mistake what I have done, even we, some students also will do in the exam. While copying the question itself, we do wrong and we will be like thinking what's happening here, why it went well like that. Okay, so let us check again how we are writing. Are we doing correct copy of the question or not? It is PR, not PQ. If I write PQ, the entire answer goes wrong. Yeah. Yes. PR plus QR equal to 25 centimeters. They told PQ is equal to 5 centimeters. So what I am doing is I am assuming I don't know what is QR, right? So I am assuming that QR is equals to X. Okay. So PR plus X is equals to 25 centimeters and PR will be 25 minus X. So I'm getting PR as 25 minus X. Now by using the Pythagoras theorem, just I'm writing in shortcut, by using the Pythagoras theorem. So what is that? Hypotenuse square is 25 minus X whole square is equals to base square plus height square. Okay, now it is in the form of a minus b whole square. So 25 square plus x square minus 50x is equal to x square plus 5 square. Yes, x square and x square is cancelled. So 25 square is what? 625 and minus 50x is equals to 25. Okay, 625 minus 25 will be 600 is equals to 50x. So x value will be is equals to 0 0 cancel, 5 ones are 5, 5 ones are 5, 5 twos are 10, x equal to 12 centimeters. So if x equal to 12 centimeters, then QR is also equal to 12 centimeters and PR will be equal to 25 minus 12, that is 13 centimeters. Done. Now we got all our values. So this is 12 and this is 13. We got it. And now we have to find out sin P, cos P and tan P. Come on, do directly. Sin P is nothing but adjacent or opposite. Opposite by hypotenuse. And cos P is equals to adjacent by hypotenuse. And tan P is equals to opposite by adjacent. Okay. Now come on, just substitute it. Opposite of sin P. What is sin P's opposite here? 12. 12 by 13 and cos P will be 5 by 13 and this is equal to 12 by 5. Done. Yes. Here is another important question and very important question because most of the times in our previous papers this question was there. And very easy. So yeah, let's go through. So they have told that tan of a plus b equal to root 3. See, tan of a plus b is equals to root 3. Always write a given first. Tell given that you can write as a stepwise based on the number of marks. Given that tan of a plus b equal to root 3. And here they also told that tan of a minus b is equals to 1 by root 3. Okay, so tan of a plus b equal to root 3. So whenever you see this root 3, you have to go to your angles table. So when root 3 comes in tan, for which degree of value you will get root 3? It is tan 60. We know that tan 60 degrees is equal to root 3. So yes, then a plus b value must be automatically 60 degrees. Then only it will be, the value will be root 3, right? So I am equating a plus b equal to 60 because tan 60 is equal to root 3. This is my first equation. Same here, tan 30 degrees is equals to 1 by root 3. So if this 30 degrees must be in the place of a minus b, then only this tan 30 will be equal to 1 by root 3. So a minus b must be equal to 30 degrees. This is the equation number 2. Now just add equation number 1 plus equation number 2. A plus b is equals to 60 and a minus b is equals to 30. B cancel, a plus a 2a, 60 plus 30 equal to 90 and a is equals to 90 by 2, that is a value is 45 degrees and substitute this a value in the equation number 1, substitute a value in a as 45 degrees in equation number 1. So a plus b is equals to 60 degrees. So a is what? 45 plus b equal to 60 and b is equals to 60 minus 45. That is 15 degrees. If you want to cross check also, you can cross check here. See, if I put a as 45 here and b as 15, 45 plus 15, 60. Yes. And here also 45 minus 15 is 30. Hence it works out. Hence A and B values are 45 and 15 degrees. Yeah. Here they are asking us to prove the identity of root of 1 plus sin A by 1 minus sin A as secant A plus tan A. So many of the students will be asking, ma'am, how can we know that what to use here? Whether trigonometric ratios or should I use angles table or identities? How can I know? So I always say you one thing. So when you see this kind of proofs, prove that this kind of questions, mostly we are going to use the identities. Okay, so the first two questions we have seen in the beginning of the video, they will be giving the values. When you see the values of the trigonometric terms, then go with the ratios only. And then sometimes they'll ask you the angles. That one also we have solved just before. So in this kind of proof questions, most of the times we will be using simple things. We will be dividing the numerator and denominator with the same term, and also we are going to uh, drag the question in such a way that I have to get the RHS. Okay, so we use all the things that we know, all the basic terms that we know. So let me solve this, and while solving only I will explain you how to think and how to analyze the question. Okay, done. So here they are told us, first let me take the LHS side. Okay, left hand side, it is root of 1 plus sine A by 1 minus sine A. Okay, but here in the RHS we have to prove a sec A plus tan A. So now go check with the RHS. What terms are there in the right hand side? Sec A means what? 1 by cos A. Tan A means sin A by cos A. So the denominator, what it is? The denominator is cos. But in a left hand side, there is no cos at all. So what I do? I now divide both numerator and denominator. Numerator and denominator with cos A. Okay. So it is a very sometimes very confusing what to divide, which term I have to divide. So check with your RHS, whichever denominator is there in your right hand side, divide with that. Let us do that now. 1 plus sine A by cos A divided by 1 minus sine A by cos A, that is equals to, now I am dividing it separately. The denominator cos A is applicable for both 1 and also sine, right? So I am making it separately. Root of 1 by cos A plus sine A by cos A divided by 1 by cos A minus sine A by cos A. Okay, I'm dividing it separately to get my terms separately. Okay, here all the terms are separate, no? So we also have to divide it separately. 1 by cos is what? Root of secant A plus sine by cos means tan A. Tan A by secant A minus tan A. I got its terms, but the denominator is there here. I don't want denominator. I want only numerator, because in right hand side only numerator is there. So what I am going to do in this kind of thing, steps, you have to cancel the denominator. So think what you can do to cancel the denominator. So I am going to rationalize it. Okay, I am going to rationalize it. So I believe that, and I hope you all know how to rationalize. So yeah, let you can see how I'm doing. Secant A plus tan A by secant A minus tan A. So we have to multiply and divide with the same term. Okay. Yes. So I just want to repeat it again. So here they have given root of 1 plus sin A by 1 minus sin A. So how to divide, which term you have to divide in the left hand side, you have to check with the right hand terms. Here in the when you substitute secant A tan A in the form of sin and cos, the denominator is cos A. So because denominator is cos A, I have been dividing the same in LHS with cos A, and I did it separately. So I got secant tan terms, but to cancel the denominator, I want to rationalize it with ck plus tan A. When I rationalize it, the denominator is in the form of a minus b into a plus b, which is nothing but sec square a minus tan square a square minus b square. The identity is 1. So I am going to get the denominator as 1 here, and the numerator, there are two terms, ck plus tan a, ck plus tan a, both like a into a square. So I'm getting ck plus tan a whole square and I'm cancelling the square and the root and I got my RHS. Yes. The second one is 1 plus, they have given 1 plus tan square. Yeah, 1 plus tan square a by 1 plus cot square. This is not 2, this is square. So while copying the question, it came like that. Okay, please ignore it. Is equal to 1 minus tan a by 1 minus cot a whole square is equal to tan square a. So let us first, so they have given first term, second term. We have to equate both of these to tan square a. So let me first take the first one, that is 1 plus tan square a divided by 1 plus cot square a. So I have to get tan square a. That is my main goal. So what can I do here? So when you see here, actually tan square a means what? Nothing but sin square a minus cos square a, right? So either I have to get sin square by cos square or I have to get directly tan square. Here cot is also nothing but a reciprocal of tan only, and both are in the form of squares. Whenever you see the terms are in squares, try to use your identities. So what is which identity has both tan and cot in it? Yeah, we have the identity uh, secant square a minus tan square a is equal to 1. This is the identity where tan is there. And we have an identity cosecant square a minus cot square a equal to 1. This is another identity. So yes, so from the first identity I'll be getting 1 plus tan square a is equal to secant square a will be is equal to 1 plus tan square a. Yeah, yes, so I can write sec, right? If I write secant square, cos term will come there in the numerator. And from the second identity, I can write cosecant square a is equals to 1 plus cot square a. So the denominator 1 plus cot square a can be written as cosecant square a. So I am substituting the numerator as secant square a by using my identity, and also denominator as cosecant square a by using another identity. Okay, now I am just writing the ratios of sec is nothing but 1 by cos square a. Yes, it is 1 by cos, right? And cosecant is nothing but 1 divided by sin square a. Yeah, we got our answer. So I'm bringing this denominator into the numerator. So 1 by cos square a into sin square a by 1. Whenever the denominator goes to the numerator, it will become reverse. Okay. 1 cancel. Sin square a by cos square a, nothing but, what is sin by cos? Tan. Nothing but tan square a. Hence we proved the first term. So yes. But now let us prove the second term, this one. Yeah. Yes. So they told that 1 minus tan a divided by 1 minus cot a whole square. They gave whole square. Okay. So what can I do here? Yeah, I can make it directly. I can make it tan as sine by cos and cot has sine by cos by sine, and I can make it like a minus b whole square formula, and I have to bring the sine square by cos square. Okay, done. Here, here I can use like that. Here I can't use direct identities because there is no direct squares here. Okay, 1 minus sine a by cos a by 1 minus cos a by sin a whole square. Done? Yes. Now take the LCM. Cos a minus sin a divided by cos a again by sin a minus cos a divided by sin a whole square. Done. Yeah. Now let us do squares for both of the numerator and denominator separately. Yes. So when I look at this term, see here, I want only sine by cos to get my tan square a. Okay. Sine and sine square and cos square are there. If I send this denominator to the numerator, it will come into the numerator place only. So sine square by cos square will be coming. But this cos a minus sine a and sine a minus cos a have to be cancelled. So what can I do? I'm just taking minus out in this term. Okay. Yeah. So if I take minus out, what will happen? Cos A minus sin A whole, yeah, divided by cos A. I'm putting separate squares, okay? I'm putting square for every term separately. By, here I'm taking minus out. Okay. Let me take the full square only. Then only this minus minus will also get squared and get plus, okay? Yeah. Okay, I'm taking full thing as square. So I'm taking minus out here. So if I take minus out, it becomes cos A minus sin A, right? I'm taking the minus out from the numerator and also here. Whole square. Done. So now minus also when it gets squared, it becomes plus only. Now this minus cos A minus sin A, this and this will get cancelled. And now I can write it as 1 by cos square A divided by 1 by sin square. And when it comes to numerator, it will become sin square A minus, sorry, by cos square A, nothing but tan square A. Yes, we proved it. So always think like what exactly you want in the right hand side, and the remaining terms, how can you cancel it? Think on that. Okay? Yes. Let us move to another question. If sin theta plus cos theta equal to root 3, prove that. I always say whenever you see proofs, always first try to divide it with some terms. Okay. If at all there is no option for dividing. See, here you can't divide with any terms because they told that is equal to root 3. They gave directly a number. So I can't divide with any trigonometric terms here. So what can I do? So always try to use your identities when it comes to this kind of questions. Okay, here there is sine and cos. So most I can use my identity sine square theta plus cos square theta is equals to 1. But identities will be always in squares, right? But here it is not in squares. So what you have to do, you have to square it on both sides and make it into squares and use your identity. Alright, done. Sine theta plus cos theta is equals to root 3. Squaring on both sides, what will happen? Sine theta plus cos theta whole square is equals to root 3 whole square. It is in the form of a plus b whole square. So a square plus b square plus 2ab, 2 sine theta cos theta is equals to 3. Come on, we got our identity. Sine square plus cos square is 1. 1 plus 2 sine theta cos theta is equals to 3. So 2 sine theta cos theta will be is equal to 3 minus 1 is 2. Yeah, 2 cancel. So sine theta cos theta we got it as 1. Oh my god, now what we have to do? But we have to prove as tan theta plus cot theta. See here it is sine into cos, but we want plus here. What can I do to get this plus? Yes, now you have to think that this 1. What is 1? Nothing but sine square plus cos square. If I write only, I will get this plus term. Yes, so I am going to replace that identity in 1. In the place of 1, I am going to write it as sine square theta plus cos square theta. Understood? Now I am going to divide it. So when I bring the sine and cos here, this term will become 1, right? So I am writing like this. I am going to divide it separately. Sine square theta plus cos square theta divided by sine theta cos theta is equal to 1. So I'm going to divide, always divide separately, then only we will get separate terms. Okay. Sine square theta by sine. This denominator is both for both the numerators, right? So I'm going to divide it for both. Sine square divided by sine theta plus cos theta plus. Now I'm getting, see, this sign is getting. We are separating two terms. Cos square theta divided by sine theta cos theta is equal to 1. Okay, now sine and sine is cancelled. Here cos cancelled. So what will be remaining here? Sine by cos, and here cos by sine. Yes, we got our answer. What is sine by cos? Tan theta. And what is cos by sine? Cot theta is equal to 1, and hence it is proved. Okay. Done. Yes. Here they are asking us to prove that sine A minus 2 sine cubed A divided by 2 cos cubed A minus cos A, we have to prove it as tan A. Okay, so don't get tension, or don't take tension, or don't be scared by seeing what is this cubed. Okay, see here it is sine, and it is also sine. Here it is cos, it is cos. So directly take out common. So we can use always I repeat again and again, whenever you see prove that questions, try to use most of the times your identities only. So here we can use identity sine squared a plus cos square a equal to 1, because all the terms are like that only. Okay, done. Now I'm going to take sine a common so that I'll get some square here. If I take sine a out, 1 minus 2 sine square a. Why I'm writing sine square? Because already one sine has come out. By cos a I'm taking out 2 cos a minus 1. Okay, done. Now what can I do here? Yes, I'm going to, so what is 1? 1 is nothing but sine square a plus cos square a. So I just want to replace this 1 with this identity. Let me see how it works. Sine square a plus cos square a minus 2 sine square a. Okay. And also in denominator also I want to do the same. Cos a I'm putting it out, and 2 this square, I'm sorry, 2 cos square a minus of sine square a minus cos square a, because I'm just directly multiplying the minus inside in the place of 1. Okay, this is what I have written. Okay, so what is sine square minus 2 sine square? It will become minus sine square a, no? So 1 apple minus 2 apples becomes 1 apple. That is minus, because minus is for the bigger sign. Sin a by cos a, cos square a minus sin square a, and even here also 2 cos square minus cos square becomes cos square a minus sin square a. Wow, both terms cancel. Sin by cos is tan a, hence it is proved. Yes, see here. So this is another kind of question. They are asking you a direct question that calculate 1 plus tan A plus secant A by 1 plus cot A minus cosecant A. You have to calculate and you have to get a number or a value. You need to get a value. Okay, you have to calculate it. So whenever you see a term calculate, it means that your answer must be either any number or a value. Okay, you have to prove it like that. So don't worry, just what you have to do is just derive this. Tan A means sine by cos, sec means 1 by cos. What you know about the trigonometric ratios, just substitute and replace those terms here. Let us do. 1 plus tan A can be written as sine A by cos A plus 1 by cos A divided by 1 plus cos A by sin A minus 1 by sin A. So you have to know the ratios very well. Done. So just take out the LCM. If I take the LCM, what will happen? Cos A plus sin A plus 1 by cos A divided by sin A plus cos A minus 1 by sin A. Yeah. Now observe carefully. Uh, let us bring this complete denominator to numerator. Okay. So then we can why I'm doing this, because I feel like this is as a term and this is b, and this is also a, yeah, sin a plus cos a, and this is b. It is in the form of a plus b into a minus b. No, so we can do a square minus b square. So I just want to bring complete denominator to numerator. So what will happen? Sin a plus cos a plus 1 divided by cos A into sin A plus cos A minus 1 divided by sin A. Yeah, see what I have done. Actually, there is no divided by. So I have been thinking in my way. So actually there is no divided by here. It's completely into. See, into, there is no divided by in the question. So this is into, okay. Yeah. Yes. Now it is A plus B into A minus B. So A plus B into A minus B becomes A square minus B square. So A square is sin A plus cos A whole square minus 1 square divided by cos A into sin A. Okay. So A square minus B square. Done. What is sin A plus cos square? Sin A plus cos square is nothing but A plus B whole square formula. Just derive it. Sin square A plus cos square A plus 2 sin A cos A minus 1. Okay. Divided by cos A sin A. Now what did you get? Sin square A plus cos square is nothing but 1. So this one and this one will cancel. So write down directly 2 sin A cos A by cos A sin A. So just cancel this and you will get the value as 2. So answer is 2. Yeah. So let us solve another question also. So yeah, prove that, the question is prove that, we have to prove sin A plus cosecant A whole square plus cos A plus secant A whole square. We have to prove it as 7 plus tan square A plus cot square A. Okay. So yes, first let us take the left hand side. Don't worry, see it, whenever you see whole square, just keep deriving whatever formula you know, apply it and start deriving it. So it is in the form of a plus b whole square, it is also in the form of a plus b whole square. So sine square a square plus b square plus 2ab 2 sin a cosecant a plus, again here in the form of a square plus b square, right? Cos square a plus secant square a plus 2 cos and secant a. So this is what I got it. Yeah. Now see sin square a plus cos square a. This is 1, right? 1 plus and yeah, 1 plus cosecant square a plus secant square a plus 2 sin a cosec a plus 2 cos a secant a. So we got this long step now. So now what can we do? We can do here, yeah, yeah, yes. See here, this cosec is nothing but 1 by sine. Yeah, cosec is nothing but 1 by sine. So I can write it as 1 by sine. Even sec also I can write it as 1 by cos. So then what will happen? This one will cancel. This will cancel. Done. So but I want the RHS in the form of tan and cot. So what I am doing, I am using my identities. I know that secant square A minus tan square A is equal to 1. Also cosecant square A minus cot square A is equal to 1. So in the place of cosec square, I can write 1 plus cot square. In the place of secant square, I can write 1 plus tan square. 1 plus 1 plus cot square A. Here, in the place of secant square, I am writing 1 plus tan square A plus 2 plus 2. So 2, 2, 4, 5, 6, 7. We got 7 plus tan square A plus cot square A. That is our right hand side, and hence it is proved. Yes. So these are some 2 marks questions most of the times often being asked in the papers. So yeah, show that cot theta plus tan theta equal to secant theta and cosec theta. Take your LHS first, okay? Take your LHS, and cot can be written as, see here, sec can be written as 1 by cos, cosec is 1 by sin. So it is in the form of cos and sin only. So you also derive the LHS like that. Cot can be written as cos theta by sin theta, and tan theta can be written as sin theta by cos theta. Alright, take the LCM now. So if the LCM is sin theta, cos theta will be the LCM, right? Sin theta into cos theta will be the LCM, and cos into cos becomes cos square theta, sin into sin becomes sin square theta. So if you are worried about how to do the LCM here, simple trick I want to tell you. Whichever is there in denominator, don't do multiply that. What is not there, multiply with that. Here in the first term, sin theta is there, but cos theta is not there. So cos theta into cos theta is cos square. In the second term, the denominator is cos theta, but sin theta is not there here. So sin theta into sin theta is sin square theta. So we know that sin square plus cos square is 1 by sin theta into cos theta. So I'm writing it as separately because in the RHS they are asking 2 terms. Yeah, what is 1 by sin? Cosec. And what is 1 by cos? Secant. Why I'm putting plus? Yeah. 1 by cos is secant theta. Yeah, we got it. Secant into cosec. A simple questions, but sometimes mostly asked questions as well. Yeah. This is another type of question mostly asked for 2 marks again. Express cos A, sec A, tan A in terms of sin A. So we have to express every term of this in the terms of sin A. So so don't worry. So we have an identity, right? Which is sin square A plus cos square A is equal to 1. From this derive what is cos square A? Cos square A will be equal to 1 minus sin square A, and cos A will be equal to root of 1 minus sin square A. Okay, so whenever cos A comes, we can write in the terms of sin A like this. Now come on, cos A is nothing but what? Root of 1 minus sin square A. We finished the first term. The second one they asked us is secant A. Secant A can be written as 1 by cos A. So what is cos A? Root of 1 minus sin square A. Root of 1 minus sin square A. We got in the terms of sin A. And what is tan A? Sin A by cos A. Yeah, sin A divided by, in the place of cos A, write down 1 minus sin square. Finished. So we are expressing every of this term in terms of sin A. Yes, in this question they're asking show that secant minus cos equal to tan into sin. Take out your LHS first. What is LHS? Secant theta minus cos theta. So secant theta we can write it as 1 by cos, right? 1 by cos minus cos theta. Take out LCM again. Take cos theta LCM. I told. So whenever LCM comes here, already cos is there. So no need to do. Just write the numerator like that only. But here nothing is there. So I have to multiply this cos theta into cos theta. That is cos square theta. 1 minus cos square is what? From our identity, sin square theta plus cos square theta is equal to 1. So sin square theta will be equal to 1 minus cos square theta. Hence I can write 1 minus cos square as sin square theta by cos theta. So I am writing it as separately sin theta by cos theta into another sin theta is there, right? Sin theta. Separately I am writing. What is sin by cos? Tan. Tan theta into sin theta, and hence it is proved. Yes. So here is another question. If secant theta plus tan theta equal to p, what is the value of secant theta minus tan theta? So whenever you see this kind of question, see it's directly an identity, right? We know that secant square theta minus tan square theta is equals to 1. Yeah. So it is in the form of a square minus b square, right? Even the identity looks like that. So we can write it in the form of a plus b into a minus b. So that's what I'm doing here. Secant theta plus tan theta into secant theta minus tan theta is equals to 1. Okay. Yeah. So they told that secant theta plus tan theta is equals to p. So I'm substituting p here and I'm writing secant theta minus tan theta is equals to 1. Hence secant theta minus tan theta will be is equal to 1 divided by p. So the value of secant minus tan is 1 by p. Yeah. Yes. So these are the very important 2 mark and 3 mark and 4 marks questions that might be expected for the exam. And I request everybody to watch the previous video, that is 1 mark questions, where I explain the formula, how to remember the trigonometry formula easily, and what MCQ questions might be asked. So if you watch these 2 complete videos, the entire basics of trigonometry will be clear for you and you will become perfect and you can attempt for sure every question of trigonometry. Thank you.